Okay, we're going to start off with the 5-1 notes. You're going to need the note packet that I gave you in class along with your homework. You should also have your textbooks, and they should be open to page 283. We're going to start talking about solving inequalities in this chapter. Now, we've talked about what inequalities are. We have equals, or equations with the equal sign, and we have not equals, which is that equal sign with the slash mark through it. But now we're talking about inequalities, and the inequalities that we're talking about are greater than, less than, greater than or equal to, less than or equal to. So just like with equations, there are several properties that we can use to manipulate them to find a solution or to find a function that we can use to graph certain situations. And we're going to start off with solving inequalities by addition and subtraction. You treat this the exact same way you treat an equation. Before we get started, today is 1/8/13 or 14. Okay, so the addition property of inequality reads, if the same number is added to each side of an inequality, the resulting inequality remains true. That's the exact same property as the addition property for equality. So if I have 4 equals 4, that's a true statement. So I'm saying 4 plus 2 equals 4 plus 2. 6 equals 6. That's still true. So what it's saying is I added the same number to both sides of the equals sign, and I got a true equation back out. The same thing happens for inequalities. So an example would be if I have 4 is greater than 2, that's true. 4 is bigger than 2. So what if I say 4 plus 3 is greater than 2 plus 3? That gives me 7 is greater than 5. Is that still true? Yes, 7 is bigger than 5. So you treat these two things the same way. I gave you the examples. If you have A is bigger than B and I add C to both sides, A plus C is bigger than A plus or B plus C, just like I did up here. Same thing if you have a less than symbol. A plus or A is less than B, add C to both sides, A plus C is less than B plus C. So if I had just had these the other way around where 2 was less than 4 and did the same steps, I'd get a true inequality. These exact same properties are true for greater than or equal to, less than or equal to. That does not matter. Okay, so here's an example. If I have x minus 12 is greater than or equal to 8, and they want me to solve it, let's pretend this was an equal sign. When they're saying solve for x, what do I have to do? I have to get x alone on the left-hand side. So to undo the subtraction by 12, the opposite of that would be add 12. Now, if I add 12 to this side, I have to add 12 to this side. These are going to cancel, and I'm going to get x is greater than or equal to 20. That's it. It does tell me that I need to check my solution. We don't really have anything to check there because there's nothing more to check. We could say if x is bigger than or equal to 20, this equality is going to be true. So let's plug 21. Let's say x equals 21. Is 21 bigger than or equal to 20? Yes, it's bigger than that. So let's say 21 minus 12. Is it greater than or equal to 8? What's 21 minus 12? It gives me 9. Is 9 bigger than or equal to 8? Yes, it's bigger than that. So when they say check your solution, they're saying pick a number that makes this inequality true, plug it into your original equation, see if it works. In this case, it did. Yes, this is a solution. On your homework, this is the answer we will grade. All right, turning to the next page. There are a few examples. I want you to try them on your own. Make sure you check your solution. I'm going to keep going on the notes here. So what I want you to do is I want you to pause the video and then come back to the video when you're ready to check your answers. So this inequality is a little bit backwards. On the previous page, it put this part of the inequality on the left-hand side and this on the right-hand side. But just like equations, that's fine. So we're going to keep solving. To solve this, we have to get m alone. Right now we have m minus 8. So to undo that, I will add 8 to both sides. These will cancel. On the left-hand side, I get 30 is greater than m. That's my solution. So they're saying, let's check our solution. I want to pick m that's smaller than 30 because they're saying 30 is bigger than m. So I'm going to go with 28 because if I were to put that in, is 30 bigger than 28? Yes. So to check my answer, I plug it into the original equation. I say 22, is it greater than 28 minus 8? I'm plugging my 28 in for my m. So 22, is it greater than 20? Yes. Again, on your homework, this is what I would grade. Okay, so let's check the next one. Same thing here. I have d minus 14 is greater than or equal to negative 19. To undo the subtraction of 14, I'm going to add it to both sides. And I get d is greater than or equal to negative 5. If you didn't get negative 5, we're talking about negative 19. So let's say you owe me $19. You pay me back 14. How much do you still owe me? 5. So you owe $5. Or if you're having a hard time with adding positives and negatives, get out your calculator and double check your work. So to check my work, I'm going to choose a d that is bigger than or equal to negative 5. I'm going to do 2 checks here just to show you something. I'm going to choose one that's bigger than negative 5, and I'm going to choose negative 5 so it's equal to it. Let's start with that. I'm going to say let d equal negative 5. Plug it into the original equation. So I'm going to say negative 5 for my d minus 14 is greater than or equal to negative 19. Negative 5 minus 14 is negative 19. Is it greater than or equal to negative 19? Yes, they're equal. That one works. Now let's choose one that's just bigger. So I'm going to go with negative 3. Remember that when you're talking negatives, the closer you get to 0, the bigger the number gets. Negative 3 is closer to 0 than negative 5. So I'm going to plug that into the original equation. I'm going to say negative 3, I'm plugging it in for d, minus 14 is bigger than or equal to negative 19. Negative 3 minus 14 is negative 17, greater than or equal to negative 19. Yes, this works. Negative 17 is bigger than negative 19. Okay, turn to the next page. This is where that vocabulary comes in. We've talked about set notation, and if you remember back, set notation was when you used the squiggly brackets to indicate a set, and you would put the elements of a set inside of it. Now, if we're talking about x's that are, ignore this, x's that are greater than or equal to 20, that's a whole lot of x's. It's every x, including 20, that's bigger than 20. So this gives us 20, 21, 22, all the way to positive infinity. And you're not going to write out every single one of those. Also, it includes decimals. So I'm not going to write out 20, 20.1, 20.2, all the way to infinity. And there's no way to write that in a set by using individual elements or the pieces inside of a set. You'd never end because it includes all the decimals, all the fractions, all the square roots, and all that stuff. So it just gets really, really big. So they take set notation and they add in a little bit of something. They're going to write it like this. They're going to say x such that x is bigger than or equal to 20. So we read it from left to right. We say x such that x is greater than or equal to 20. This piece comes directly from here. This piece is set builder notation. So we're going to write that. Let's write it out in verbal form. We're going to say x such that x is greater than or equal to 20. Now, that's kind of confusing, so to put it in simple terms, what it's saying is x's can be any number. We know that that goes all the way from negative infinity to positive infinity because it's a variable. But we are only concerned with x's that are bigger than or equal to the number 20. So I'm going to say that again. X can equal any number, but we are only concerned with x's that are bigger than or equal to 20. That's why they put it in set notation, because that bigger than or equal to 20 gives us everything from 20 to positive infinity, including the decimals and the fractions and the whole numbers, all of them. So the only thing you need to remember is that you have to have x, a line, and then your solution. So let's go ahead and do this example below. We have x minus 12 is greater than or equal to 8. So to solve it, I'm going to add 12 to both sides. And I get x is greater than or equal to 20. Okay, that was the answer I got up here. So to write that in set notation, I'm going to say x such that x is greater than or equal to 20. Okay, that's all you have to do for set builder notation. We can also graph inequalities. If we were graphing x equals 20, you would just have a number line and you'd put a dot at 20. But we're not talking about just equal to 20. We're talking about 20 and everything bigger than it. So when we start doing these, we have to put a dot where our solution lies, and then we have to include the greater than or equal to part. Now, we know it goes at 20, so we're going to put a circle. This is where things kind of get tricky. This is greater than or equal to, so our circle is filled in. That basically just means we have to include 20 in our answer. So it also says everything bigger than 20 is included in the solution. So when we talk about bigger than 20, we're talking about everything on the right-hand side. So we start drawing arrows. That's how we graph inequalities. Okay? You put a filled in circle because it has the equal to symbol underneath of it. And you draw the arrow to the right because it includes everything bigger or to the right of that number. Okay? We're going to do one more example, and then I'm going to have you do a few on your own. So again, we have x minus 12 is greater than 8. The difference here is this was greater than or equal to, and this is just greater than. So again, I'm going to add 12 to solve. I get x is greater than 20. So when I write my set builder notation, I get x such that x is greater than 20. The difference here is that equal to symbol. These are a little bit different, so these will be a little bit different. So when I go to graph this, I'm going to have a circle at 20 again. This time it is not going to be filled in. It does not have the equal to symbol underneath, so it doesn't include 20. But it includes everything to the right of 20. So we have our open circle, and then we just draw our right arrow again. Okay? That's it. So turn to the next page. Oh, I guess I don't have any more examples for you. We'll get there. So we've talked about adding a number in order to solve. We've talked about set builder notation, and we've talked about graphing. Now we're going to talk about the subtraction property of inequality. That's the exact same thing as the addition property, what we just did, except for you're going to be subtracting your answers. I want you to turn back to the very first page of your notes. On the first page, you see how when we started solving, in order to solve these, we had to add a number. The same is true for any of the other examples that we did. We had to add a number in order to solve. The only thing that changes for the subtraction quality is that you'll be subtracting a number. So if I have A is greater than B, then A minus C and is still greater than B minus C. So if I have, let's see, if I have 4 is greater than 1, that's true. Let's say 4 minus 3, is it still bigger than 1 minus 3? I subtracted the same number from both sides. So I get 1 is greater than negative 2. Still true. Okay, same thing for less than. A is less than B. If that's true, then A minus C is still less than B minus C. Same thing is true for greater than or equal to and less than or equal to. So I want you to go along with me on this one. We're going to use a subtraction property in order to solve it. Then we're going to graph it and write it in set builder notation. We're not going to be worrying about checking our answers anymore for the rest of the notes. So I have m plus 19 is greater than 56. In order to solve, I have to undo this addition. To undo addition, you subtract. Okay, so I get m is greater than 37. Double check my work. Let's see. We have 37 plus 19. Yep. Okay, so m is greater than 37. That's my solution. To write it in set builder notation, I say m such that m is greater than 37. Okay, now to graph it, I'm going to put a dot at 37. It will be an open circle because it does not have the greater than or equal to symbol. It doesn't have the equal to part. Now it says bigger than 37. So again, we draw to our right. We've only had greater thans. We're going to get to some less thans. Because we draw to the right on greater thans, we draw to the left on less thans. Okay, next page. Remember that sometimes we can get an equation with a variable on both sides of the equal sign. The same thing is true for inequalities. You can get variables on both sides of the inequality sign. But don't forget, just like in equations, you can move those terms that have variables in them to either side of the equation by adding or subtracting. We've done that before. So let's do an example. We have 3a plus 6 is less than or equal to 4a. So, oops, that looks like 49. 4a. So, we have 3a on this side and we have 4a over here. But in order to solve, we have to have all the variables on one side. So I'm going to move one. The 3a makes more sense to move because I'm going to have to subtract one of them because they're both positive. If I move the 3a over, it will stay positive because it's the same, because 4 is bigger. I always want you to try to keep them positive because when you get negatives, things change for inequalities, and we're going to cover that tomorrow. So for today, when you are moving variables, you need to keep them positive. So I'm going to start by subtracting 3a. Cancels over here. I'm left with a positive 6 is less than or equal to 1a. Now remember, 1 times a is just a. So I get 6 is less than or equal to a. That's my solution. So to write it in set builder notation, I'm going to say a such that. Now, when I was talking about set builder notation, I always had the variable on the left-hand side when it came to this part of the set. So I still want that to be true, so I'm going to write the a first, but that means that my inequality symbol has to flip because a is bigger than 6. Okay, so because I flipped these two around, I also have to flip my inequality sign. So now I have a such that a is greater than or equal to 6. Okay, these two things are the same. They're just flipped, which means the inequality symbol has to flip. And then I chose this one to put in my set builder notation because the variable came first, and we want that to happen. So now to graph, we have to write in our number line. I left this number line blank because I want you to be able to decide how should I label a number line. Do I start with 1? Do I start with negative 100? It kind of depends on your solution. My solution includes the number 6. So I know that I'm probably going to go with putting 6 in the middle. Okay? To graph this, I put a solid circle at 6 because it includes the equal to symbol, and it's saying it's bigger than 6. Again, we we draw to the right. Okay? I want you to go ahead and solve the bottom example, and then we'll come back and we'll talk about it, and then there's a summary on the back page. I'm going to keep going, so you need to pause this video and then do the example yourself and come back to the video when you're ready. Okay, so to solve this, I have 5h is less than or equal to 12 plus 4h. I know that I have to get all the h's on one side. I'm going to move the 4h because it's smaller, and I want it to stay positive. Remember, on your homework for today, it needs to stay positive. It changes things if it's not. So I'm going to subtract 4h from both sides. I get 1h is less than or equal to 12. Now, 1h is the same thing as just h. h is less than or equal to 12. Okay? You also had to write this in set builder notation. That would look like h such that h is less than or equal to 12. Okay, and then to graph, I have to draw in the numbers for my number line. I know I have 12. I'm going to put in the middle. Okay, I'm going to have a solid circle at 12 because it includes the equal to sign. And I'm going to draw my arrow to the left because it's less than, so it's talking about everything smaller than the number 12. Okay? All right, let's turn to the next page. I just kind of summarized everything that you're going to see on your homework. We've talked about less than, that's what this symbol is. We're going to say open circle for when you're graphing. Arrow to left. Greater than is still an open circle. And it's an arrow to the right. These are just keys for when you're graphing them, okay? Less than or equal to is a solid circle. And it's an arrow to the left. And then greater than or equal to is a solid circle, arrow to right. Okay, that's the end of the notes. You need to take a look at the homework. Email me any questions that you have about the notes. Remember, tomorrow in class we will go over examples from the skills practice and word problems page, and I'll see you in class.